Hi, welcome to Visual Studio Toolbox. I'm your host, Robert Green, and joining me today from the Visual Studio team is David Kean. Hey, David, how are you?
Yeah, not bad, Robert. Thank you. Thanks for the having me on.
Yeah, we are going to talk about performance improvements in Visual Studio 2026. Before we do that, why don't you introduce yourself to the viewers in case they don't know you?
Okay. Hi, I'm David Kean. I'm a principal engineer on the Visual Studio team. I particularly focus on performance. Um, I've been on the team for about the last 5 years.
Mhm.
Before that, have been up and down the stack on C Sharp, .NET, CLR, and mostly spent my career at Microsoft on the Visual Studio tools and runtimes.
Cool. So, Visual Studio 2026, the latest and greatest version, has just appeared. And there are performance improvements. Now, we every release we hear about performance improvements and we kind of come to expect them. What's different or new this time around?
Thanks for asking, Robert. This time around, we have made a concerted effort to spend energy in areas that we typically try not to regress, but not overly improve every release. In past releases, you might have seen us move to 64-bit. In the last release, we make improvements in solution load time and build time and all sorts of scenarios inside the inner loop. For 2026, we wanted to spend a little bit more energy on what we're thinking about, what we call startup and startup-like scenarios. So getting you into the code as quickly as possible.
So, is that like file new project or file open project?
It starts from process launch. We start from the very time we get CPU right to the point we open your solution and have the code straight in front of you. The other thing that we've been working on, not only are we working on or have worked on the actual startup time, i.e. moving the duration it takes for you to get to your code, we also did a bit of work on perceived performance, which tends to be super important as well.
So, you released the previous version, it's faster than it was before. And, many people think it's great. Some people, or hopefully not many people, but some people think it's slow and in particular areas. And then you keep track of where the complaints are and how do you identify the areas that are slow and what means slow? What is slow?
We probably start with our performance lab, which is in the first place, which is imagine we get a lot of feedback around a particular area being slow.
Mhm.
Well, we want to first get a reliable repro, and that involves setting up consistent tests that repro the situation
Mhm.
and set them up in our performance lab. And our performance lab is designed to give a very, very consistent run after run duration of the scenario. Now, it measures durations, a lot of it, but it's also about resource usage. So our lab measures, how much allocations Visual Studio might use in a scenario. It measures CPU usage. It measures how many DLLs we load.
Mhm.
It measures how much memory we use. Those sorts of things. So the first thing we do is get something consistent and in the lab, and at that point, then we kind of break it down and try to look at why it might be slow. Is it actually blocked on CPU time? Is it actually consuming a lot of CPU trying to load some sort of cache? Is it allocating a lot, which causes freezes, which also slow down duration? Fitness is also affected. Or it could be just blocked on, say, a network call or some I/O, some operations that perhaps it shouldn't be blocked on. But it's a variety of different things. We see lots of things in the lab. Sometimes Windows gets in the way of loading our DLLs sometimes, and Defender and third-party antiviruses and things like that. The lab is mostly about trying to get a repro. And now you have to be careful with the lab is that to aim to have consistent runs, run to run, we also tend to turn off things in the background that users don't. For example, we might turn off some scheduled tasks that are in the background from Windows, or we make sure that nothing's running in the background nothing's overlapping. We might wait for things to kind of settle before we start running the test. In the real world, that's not how users work. So
Right.
it's really more about not trying to get a representative duration of what users are hitting, but more about just measuring resource usage.
Okay. Obviously, some of what makes things slow is out of your control. So if I'm loading a solution with hundreds and hundreds of files and I move from a slower hard drive to a much faster hard drive, then presumably it loads much faster. And that's got nothing to do with Visual Studio. Is that true?
Well, not entirely true. I mean, it
Okay.
is true. Visual Studio does run faster on faster hardware. And if you don't have an SSD right now, then please upgrade because that's going to be your biggest bang for your buck for that one.
Right.
We can change the way that we load things. We do actually measure. So on a spinning disk for the old style spinning disks, seeks are very expensive there.
Mhm.
So if we have a lot of threads trying to hit the disk at the same time, that will slow down those operations because the disk is and the spindle is going back and forth between those two different threads. If we're in startup time, we might be loading lots of DLLs and code.
Mhm.
On spinning disks, that's very expensive. We have to page that data in from the disk. On an SSD, that's kind of almost free. So we measure both spinning disks and SSDs in the lab. We kind of model what our behavior would be on a spinning disk and look at to that to get an estimate of what it looks like on a spinning disk so that we don't just assume that everyone has the same hardware.
Okay.
We also tend to underpower the lab machines as well. That kind of helps. But it also hides some other issues that you get when on higher core machines. So it's kind of a trade-off back and forth on those.
So slow is obviously a very relative term. What is slow to me might be pretty zippy to you. And what I think is slow might be as quick as the product ever gets. So how do you define slow, too slow, fast? Very relative terms. And I can imagine people have different opinions. How do you come to a decision on that?
So combined with the lab where we've got consistent results, where durations tend to not move up and down without regressions or improvements. Combined with that, we have product telemetry, which we measure in the wild, the same scenarios. We look at various percentiles. So a common percentile that we will look at is the 75th percentile of a scenario. So a 75th percentile means if we have 100 people who all started Visual Studio or 100 startups, and we pick the 75th slowest one.
Okay.
That's the 75th percentile. And so we tend to track the 50th, the 75th, and then the 90th percentiles. When you start getting into the 98th and the 99th percentiles, then you're starting to see, failing disks and very big outliers. We tend not to use average durations in the wild because they tend to be very influenced by very fast machines and lots of startups or very slow machines. Mostly we use percentiles to track that. So we tend to have a test in the lab and then a measurement in the wild to try and keep us on track. You asked a question about what seems fast. Well, I mean, it's never fast enough for me at least. I just keep going until I can't move it. That's
Okay.
what we tend to do is we when you start measuring a scenario in the first time, you tend to see a lot of low hanging fruit, like very simple changes that you can make to how it works to make very big movements. For most scenarios start like that. If no one's ever looked at the perf of a scenario, you can almost guarantee that you can move it. Once you've got rid of the big low hanging fruit, now you've got to start making a little bit more harder decisions. Am I going to run less code here? Am I going to change the design of this so that it doesn't need this large infrastructure behind it? Or am I going to put a cache in front of this thing? Might I delay how this works? Or might I turn the feature off by default? But when we look at perf, mostly we try to focus on, can we just make it faster before we go and talk about turning the thing off? Or maybe we load it in a different way, a bit smarter.
Let's talk about when new features are added. So one of the new features in 2026 is mermaid charts, right? We've done a couple episodes on that, and it's really, really cool, right? You have this mermaid syntax that you don't even have to write yourself. And then next thing you know, Visual Studio creates a chart. So going into that, did you have a perf goal, or it's just pretty fast to begin with, so you didn't necessarily focus on that as compared to something like when you added Copilot? And Copilot, first you got to wait for the interface to show up, and then how fast does it respond to the questions you've asked, and how long does it take to think and retrieve information, and then how long does it take to type out its answer, let alone change your code? I could see, some features are pretty quick to begin with and others are very, very complex. So I guess let's talk about adding Copilot to Visual Studio. Going in, did you have a sense of what would be quick and what would be slow? And did you kind of know where the areas would be that you could focus on? And then a follow-up would be, how much perf improvement have we seen and can we expect on that?
Often when you say, let's say you pick Copilot. Often when you start with something like Copilot, it tends to start off at a prototype, right? The aim is to move super fast. So you might we haven't released it at that point. We're just iterating, trying to proof of concept. Can we build this thing? Will it work? We tend to avoid thinking about perf at that point
Okay.
because we tend to throw away a lot of prototypes. Then when you start getting a bit more serious with the thing, and you go, yes, we want to ship this. Well, at that point, we start talking about what kind of scenarios we want. We've got many Copilot tests in the lab, measuring lots of different scenarios from, the opening the signed out windows where you don't have a prompt, to the prompt showing up by default, to opening a thread by default that you've previously had, or its impact on typing, its impact on editing in other parts of Visual Studio. We tend to try and cover a broad scope, especially something as important as Copilot. We want to make it fast. Copilot has got a big bump in 18. We've spent a particularly large amount of time trying to speed up its dependencies, which actually improve more than Copilot. Copilot happened to just get a lot of this for free. For example, it waits on our extensibility cache to be loaded before it can start. Well, that cache, when we started, that was, say, about 900 milliseconds in the lab. It's now about 250 milliseconds in the lab now, and we're loading it now way before any window needs it. So Copilot no longer needs to wait for that. That's an example of how we've sped that up. Some other examples would be Copilot is built up of a couple of editor controls. Now, when you traditionally think about an editor, you're thinking about code and, you're editing a C# file or a C++ file. But in the Copilot window, there's actually two editors underneath. One is the prompt and one is the response that you're getting back. When we looked at the perf of that, the editor team found that, Copilot was paying the cost of things that it wasn't using.
Ah. Mm-hmm.
And so, we were a bit smarter about how we would fire that up so that Copilot didn't have to pay for things that it doesn't need within those within the windows. And then we spent a bunch of time changing startup, actually significantly changing startup. Startup's changed probably the most it's ever had this release. In the past, startup was very single. It has been for the past 20 years, or 20 to 30 years, has been single threaded right up until the point we start loading solutions and files. So this release, we kind of changed how that worked, where when you open a solution or you're opening a tool window, we're opening VS for the first time, you might double click a file or you might double click a solution. We already know what we're going to load for that solution and for those files. And so we start preloading those things very early into the process lifetime.
Okay.
Now, in the past, that would have been very challenging for us to do because some of those things are very UI thread heavy. In the past, they might have been an STA COM object, which is hopefully no one has to deal with those these days. But we in the past, Visual Studio had a lot of STA based COM objects. Means that every call to them needs to happen or be marshaled to the UI thread. So you'll be on a background thread, you'd call a method. Well, that needs to put a message on the message pump, which is a set of messages that the UI is waiting for. and it's intermixed with user clicks and user operations. And we would have to pump those messages and run them, and before we send a message back. Well, those things that slows down the process quite a lot. It hurts responsiveness because we're running a lot. We're intermixing our own code with the users' clicks and responding to those. The last year, we've rewritten quite a lot of those core components to not be STA. They're all pre-threaded. They don't need the UI thread. So because they don't need the UI thread, and we now can just load them in the background before they're even needed. Now, when the Copilot window goes to show, it's no longer waiting for those components. They're already done for it. That's how we would approach something like that. Typically, is just put it in the lab, keep iterating on it, make sure we're measuring in the wild to make sure that we're actually influencing the wild, because there's no point moving something in the lab if it doesn't change what users are experiencing. It's hard to mimic every single user scenario in the lab. So telemetry can often show outliers and that are hitting a lot of people. We tend to investigate those, add more telemetry to the product until we can figure out what they are, then go and fix them, and then try and repro that in the lab so that we don't regress it. So it's just this back and forth between the lab, measuring it out in the wild, what customers are experiencing, making changes to make sure that we address all the issues that they're hitting, and then try and get that in the lab. And then that's what we keep doing, iterating over iterating.
So the measuring must be a huge amount of data, yes?
The measuring is, Visual Studio has quite a lot of performance data being sent back to us, but measuring it's designed in a way to not influence performance too much. We have very good systems where we can actually record short traces as well. Imagine we catch a high CPU usage in the wild where Visual Studio is using a lot of CPU. What we might do if we have a sampling thing where we say, okay, do we want to sample this one? We might sample 1 in 100 issues that we see in the wild. When we start sampling, we record a short trace for about 60 seconds. We zip that up, send that back to Watson, and we have some back-end systems that kind of aggregate that data and then slowly blame particular methods, and then we go and fix the top ones of those. It's also very good at finding regressions as well. So we can compare between what was top hitters in 17.13 versus 17.14, or are there new things showing up in 2026 that we didn't see in 2022? We have a very, very good backend system that kind of does a great job at basically giving us very accurate blames on what users are hitting in the wild.
Do you want to show us some of that data?
Yeah, sure. I can show some of that. Okay, so I started talking about we had our lab, our performance lab. Our performance lab, we've got a series of tests. In this particular case, I've got this one here, C++ v64 solution management. And we have a scenario within that that is just measuring the start of VS. So it measures from when VS was launched to when we consider ourselves done.
Okay.
So when we consider ourselves done it's actually measured in an interesting way, in that at the end of startup, when we think we're done, what we do is we put the lowest priority message on the UI thread that will get run after every single other message is run. What that catches is, if we were only going to measure when we think we're done, started to when we think we're done, we'd miss things like asynchronous work that was kicked off in the background that would come back to the UI thread and still freeze the thread while the user was interacting with VS. So we want to catch regressions. We want to make sure we're trying to catch the experience that users are hitting in the wild. Here we have these things called counters. So counters are the things that are measuring resources. And in this case, I can see that it's measuring duration. In the build that I've picked here, this is what our measurement rate is. We measure how much allocations this scenario uses, how much CPU, because we want to make sure we monitor CPU, even though it might not interrupt or influence duration. We measure how much ref set. So ref set is when I was talking about the spinning disks. If you're on Azure machines and spinning disks, they tend to have very high paging costs. And so ref set measures how much data we're paging in from that disk. The more data that we're paging in from the disk tends to be code, the more costly it will be to start up on those machines. That's measuring cold cost, which is you've just rebooted your machine and the caches are all cleared. Once you've loaded VS on a machine, it tends to be in memory cache. So this makes less sense after you've loaded us for the first time. And we measure a bunch of other things, like, for example, how many times we switch to this main thread from background thread during it. If I look at duration here I've got a trend line from builds over a few months, or what have I got? Over actually a year and a bit, a year and a half. You can see that this scenario started at about just over 1400 milliseconds. This is milliseconds here. You can see some regressions, and then when we've addressed those regressions, these things run on every PR that comes into VS. Mostly people don't merge on regressions. Occasionally we have to, just to be able to integrate two different teams' code. Sometimes we have to merge on regressions and keep them in the product temporarily. They never get out to the customer, but they stay in our main branch.
So what does that mean, merge on regression?
So, for example, here, someone has merged in a change that has increased startup time by about 100 milliseconds. That would have blocked their PR from merging.
Okay.
And then they would send an email off to we have an exceptions group where they would explain, we need to go and do this and this before we have to merge this in to unblock this other team. And then we approve it, or temporarily approve it mostly. And then with the promise to go back and fix it. And that's what they've gone here, is fixed it here.
Right. Okay.
And then you can see that the trend line is slowly going down and until we're at this point here. This is what we ended up shipping in some of the early previews for insider builds for 2026. This is basically launching VS without anything, just an empty environment. It's not showing the start screen. It's not showing opening any solution or files. I've got another one here.
So it went from 1.6 seconds to 1.2 seconds?
Yeah, about it floated just above 1.4 seconds,
Okay.
down to about 1 second, just over 1 second here.
Okay.
The way I kind of like to think about these numbers is, you have to remember that these are warm loads that are repeatedly run on the same machine, designed to not have too many durations, but not have too many differences between each run.
Mm-hmm.
You can see that there's some peaks over here and peaks over here. Every time we have massive differences between runs, what will happen is you'll end up sneaking in regressions without knowing, because they'll sometimes come under one of the peaks. We try to make them very consistent. So making them very consistent means that it's not what the user experiences. I tend to have a number in my head when I'm looking at this number, so I can measure what it's going to be at the 75th. So at our 75th percentile, so if we looked at the fastest 75th percent of, from 75th downwards, I would times this number by about 3, and that would get me approximate 75th number. So the 75th at this number here would be about 3 seconds.
I see. Okay.
25% of startups would be above that. We've got some other examples here. These are just some of you're seeing here are some of the improvements we've made in 2026. Okay, this is measuring our new responsive solution load. In 2026, we actually changed, like we changed startup, we actually changed solution load quite a lot in a way that we've never changed it before. In the past, if you ever opened a solution, you would notice that if you tried to interact with Visual Studio, you wouldn't be able to. It would end up ghosting, and we would be blocking on it on the UI thread. Well, in 2026, we've gotten rid of that. So now we're loading it completely on a background thread. You can interact with VS. You can move it to another window. You can, close tool windows, do various operations while you can close VS while it's opening, which you couldn't do in the past. And so this is measuring our new responsive load. And so we started over here at about 4.5 seconds. And then this is what we ended up have shipped in recent builds.
Nice. Yeah.
Down to 3 seconds.
Definitely faster.
This is us just being a bit smarter about how we load these things, just making sure that by the time we block on it, Visual Studio is we kind of load on demand. We try not to load every single feature. That means that we tend to load the feature at the point we need it. But that also leads to bad performance, because if you only load it at the point you need it, it now has to wait for that thing to load. So we're just a bit smarter here. So we start parsing the solution file at about 300 and 400 milliseconds into open. Then we start loading the things that it needs up front behind the scenes. And then by the time the IDE needs it, it's ready. So that's how we get these things. This is measuring devenv foo.txt. So you've double clicked this text file out in Solution Explorer. I mean, out in File Explorer. Over here, we've started at about just over 3.5 seconds. If you were to go and look at this at what it looked like in 2019, it would be about 4.2 seconds.
Mm-hmm.
And then you can see that in current builds now, we're down to about 2 seconds.
Nice.
And the funny one, this one, we haven't even really scratched the surface on this one. So we can keep moving on this one and get it down quite nicely. So that's how we're measuring it in the lab. From once we got it in the lab, we tend to break it up and understand how it works. So here's how Visual Studio Startup worked at the start of 2026, or Dev 18, what we call it internally. And this is just a time graph of single threadedness. This method calls this method, that calls this method. And then finally, the IDE is considered finished here. And these are the individual components inside of those things. What we've done is we've grabbed these components and we just started loading them up, behind the scenes, and made things a little bit smarter about how we load it instead of synchronously blocking on each one. Just making better use of machine resources. Most machines have lots of cores these days. At least 4, 2 to 4 to 8 to 16 cores that we can make use of, and that's what we've done. So once we've done that, then we go out, and this is our live data. Once we start measuring that in the lab, we can see that we're reducing stuff, but is that reducing it in the wild? Well, that's what we've got this for. So here we have devenv startup at the 25th percentile. It's about 1.3 seconds at the 25th percentile. Now, when you're looking at this, you have to remember that this is the first load after Windows has started, and it's also warm load. So if you were to exclude those two, the warm load would look much faster. And then you can see it compared against the prior versions of us. We're reducing down the each release. We just keep going a bit further. And then once we have those sorts of things, then we have lots of data that we collect if we see regressions, then we want to collect data to, or understand the data to why did we regress. So here's a little dashboard that we have built over the top of our data here that just shows UI thread time for startup, what features are blocking the UI thread, how much are they looking for, how much are they doing that.
Mm-hmm.
And we're just looking for regressions, and you can see that this package is missing. That was a regression that we accidentally introduced in 17.13 that we fixed in 17.14. And so we can see that disappeared, which means that we've addressed that issue. I was talking about our tracing. We have these tracing systems. Here's a set of failures. They're kind of like, if you think about Watson, most people know what Watson is around crashes. Well, we have the same systems for CPU, for memory, for allocations, for thread time, thread pool and so forth. We have lots of systems that kind of measure and blame at the per method level. And so this method here has been blamed for, in the times that we caught it, we saw it in every time we sampled, we saw it about 8%. At that time that we saw it consuming about 1/5 of a core at the 90th percentile there, and just under 1/5 of a core at the 50th. And so we have these backend systems, we file bugs, we get them fixed, we address, we can compare them version to version.
And again, this is data that's being collected from actual users using the telemetry in the product, right?
Yes, this is short traces that we recorded when we detect a problem. So in this case, we detect that the Visual Studio has used too much CPU, more CPU than we would expect. And so then we capture a short trace, and then our backend systems aggregate it and end up blaming particular things. We have the same for allocations. When GC time is too high, we'll measure it and capture a really short trace and aggregate it on the back end and then fix it. So we've got very actionable data around the regressions, and we're constantly trying to improve and bite off the top ones every release. So that's why Visual Studio, that's why we keep getting better each release.
Yeah, that's been a really fascinating look behind the scenes. Because, as a user, I hear, oh, it's faster, and I believe it, and I can sort of see it. And now I have a much better sense of how you actually learn, uh, identify things that are issues that I, as a user, might be reporting to you. I don't even know that there's anything wrong, yet I'm reporting that there's a problem. You're going to notice it. Many, many other people have noticed it. And in the next release, it's fixed. And I didn't even necessarily know that I was reporting on a
Yeah.
problem, and then you go and fix it. That's awesome.
Yes. Yeah. When we do prioritize customer reports. So if they do
Mhm.
report a problem, then that
Sure.
will bump the priority. But for the most part, we know what's slow in the product. We know what's not responsive. We know when we're not responsive. So we know those problematic areas, and that's the ones that we go off at and bite off mostly. We also pick off certain areas where, for example, there might be less users using a particular feature, but those users are having a really bad time about it. Well,
Right.
we don't want to throw those users' experiences away because they get lost in the noise. So we also target those. We have the ability to target particular set of users who use features, so that we can see what the top issues that they're hitting.
Well,
Which
kudos to you and the entire team for all the great work and the amazing amount of time you guys must be spending on this.
yes,
Um,
you're taking me away from being able to fix some issues right now. Actually,
well, I'll let you get on with it then. Thanks so much for coming on and sharing this with us.
appreciate it, Robert.
Hope you guys enjoyed that. We will see you next time on Visual Studio Toolbox.